Okay, so it's actually really cool that we can use the first derivative to tell when a function is increasing or decreasing. So without looking at the graph, we can just use the derivative. And here's why. So if we graph a function, and I'll just make a parabola, so it's going to be decreasing for a while and then increasing. So do you remember what the derivative means? The derivative means the slope of the tangent line. So let's look at, so up to here, whatever that value is, from negative infinity up to this point, we're decreasing. Well, let's look at some of those tangent lines. So maybe we'd have one here. These aren't obviously super accurate. Okay, but that's 3 tangent lines. And all of them are decreasing tangent lines. They'd all have negative slopes. So while our function is decreasing, the derivative is going to be negative. Well, what about when our function is increasing? Well, then our tangent lines are all going to be increasing lines, okay, which would all have positive slopes, which means our derivative would be positive, greater than 0. And at the minimum point, right, we've talked about this, that's where the function is going to have a 0 derivative. Okay, so here are our rules. If we have a continuous function and it's differentiable, if the derivative is greater than 0, positive, then our function is increasing. So we can find the intervals where our function is positive, where the derivative of our function is positive, and that's where our function will be increasing. Okay, then it says, suppose it's continuous and differentiable, then if it's negative, then our function is decreasing on that interval. Okay, so this says find all critical values of f of x and determine where f of x is increasing or decreasing. So we're going to take the derivative here, f prime of x equals 3x squared minus 7. So we're going to set this equal to 0. It's always defined, so we don't have to worry about it being undefined. So x squared would equal 7 over 3. We'll take the square root of both sides, so x is going to be positive or negative square root of 7 over 3. Now, if we want to be kind of completely correct, or completely following tradition, we would separate these and then we would multiply by the square root of 3 over 3. So x is going to be plus or minus the square root of 21 over 3. So that's where our derivative is equal to 0. So we're going to make a sign diagram. We're going to put the two places where our derivative is 0, negative square root of 21 over 3 and positive square root of 21 over 3. Which, if you want to know about what that is, just to kind of help you picture it, you can do the square root of 21 divided by 3. So that's about 1.5. This would be about negative 1.5. This would be about 1.5. So we want to test, is it positive or negative on each of these intervals, the derivative. So I like to put an f prime on this line just so I remember where I'm plugging stuff in. Okay, so I want to pick a number less than negative 1.5, so I could pick negative 2 and plug it in here. So we would have 3 times 4, which is 12, minus 7 is 5. And all I care about is that that's a positive number. Okay, between these two I can pick 0. If I plug in 0, I get negative 7, so that's negative. And if I pick something bigger than 1.5, say 2, again I'm going to get positive 5, so that'll be positive. So what we would now say is that f of x is increasing on the intervals where we just put a positive sign. So negative infinity to negative square root of 21 over 3. and from square root of 21 over 3 to positive infinity. And then we're decreasing from negative square root of 21 over 3 up to square root of 21 over 3. Now we'll talk about this a little more, but if we go from increasing and then decreasing for a little bit and then increasing, we can see that we're going to have a local max at x equals negative 21, square root of 21 over 3. And we would get the y value by plugging it back into the original, and we'll have a local min at x equals square root of 21 over 3. Okay, so just by solving where is the derivative greater than or less than 0, we can find where is the original function increasing or decreasing.